Welcome back to the channel. Thank you so much for tuning in today. And we have some pulley problems that we will be solving here today. And I hope you learn a few things on how to solve pulley systems. And we will start with exercise number 3.58. And I have an engineering static book here. Everything is in equilibrium, nothing is in motion. Okay, so we will be checking out 3.58, this exercise here. And these are the diagrams we have. And this problem states that pulley systems containing 1, 2, and 3 pulleys are shown. A only has 1 pulley, and B has 2 pulleys, and C has 3, as you can see. So neglecting the weights of the pulleys. So all these weights, we will be neglecting their weights. Even though they have a mass, we're gonna neglect. So determine the force T, this tension here, required to support the weight W, this mass here, in each case. So we will start by doing A with only 1 pulley, and we're gonna draw a free body diagram. I have a sketch pad here, and I have my calculator. So we're gonna check it out. So here, let me explain this first part with the 1 pulley. So we have a tension, a cable attached on this pulley right here. It's going around the pulley, and this cable right here is attached to a fixture on top, this line right here. Okay, and it goes down around the pulley, and there's the tension that we're looking for, and we have a weight W suspended on this pulley. All right, so let's check A first. This is gonna be hard for me to write, but I hope. With 1 pulley. Okay, so we're gonna draw a free body diagram, FBD here, and we have the pulley right here, and we have a tension, a cable going around it. So here you can see that this tension is the same cable around the pulley. So this one we will both call it T. And then we have another tension that's suspended, that is attached to the weight W. And we will call this W. So looking at this, and remember, we are neglecting the weight of this pulley right here. So we have T and T here are facing up. So we have 2T minus W. W is suspended down. So this one will be minus, and it is equal to 0. So if we solve for T here, we will find the value of the tension required to keep the weights, the block right here, to support the block. So we're gonna solve for T, I mean. So we have 2T is equal to W, and if you divide by 2, then you will get that T is equal to 1/2 W. Okay. So for part A, so we need half of this weight to support the block. Half of the whatever W is, we need half of it to keep it suspended. Okay. So we're gonna move on to part B. and B said, and for B, as you can see here, we have 2 pulleys, okay? And this cable right here is cable T, and this second cable here is not the same as cable T. So we can call this T1 if we want. And remember, we're still neglecting all the weights of all the pulleys. So we have T going around and T2 going around the second pulley. And then we have another weight suspended below pulley number 2. So this is what we will do. We will draw a free body diagram. To make it simple, we're gonna make a free body diagram for every single pulley. So we have 2 pulleys here. So we have the same cable around pulley number 1, and then we have cable number 2 that goes around cable 2 is attached on the pulley number 1. So we will just draw that cable, and this one is T1, and this is T, and this one is T. So we will just put here pulley 1, and then our pulley number 2, as you can see, it's coming from here, it goes around pulley number 2, and then it goes to the fixture up here. So this one is T1, and this one is also T1. And then we have another cable, and this one we can just say that it is the weight that is attached to it. So this one is W. Okay, so let's make 2 equations for every case, and then I'll put B here. So equation A is 2T, because this tension, this cable here is facing up, so it is 2T minus T1. T1 is facing down, which is equal to 0. Because remember, all these equations are Newton's second law. F equals mass times acceleration. But since here we don't have any motion, everything is in equilibrium, it is just F is equal to 0, because acceleration is 0. So anything multiplied by 0 is 0. So that's why we're having a 0 on this side here. And B, we have T1. Here T1 is positive. So, and we have 2 T1s. Minus W, the weight is suspended down, is equal to 0. All right. So we're gonna solve this first equation for T1. We're gonna solve this equation for T, so 2T is equal to T1, and then T is equal to 1/2 of T1. All right, so, and for B, we're gonna solve for T1. So we will have the same kind of stuff. So 2T1 is equal to W, and T1 will be equal to 1/2 of W, because negative W, if you move it to the other side, it will be positive, right? So we have 1/2 the W, and then if you plug in T1, if you plug in for T1, so T is equal to 1/2 of T1, and T1 is 1/2 of W, right? So then we will get T is equal to 1/2 times 1/2. I would, since I've already calculated this equation, I know it is a quarter. So we will just multiply 1/2 by 1/2, which is 0.25, and 0.25 is a quarter. So 1/4 W. As you can see here, for T, when we have 2 pulleys, we have we need even less tension. We are required to put in even less force to keep this weight suspended. Because when we had only one pulley, we needed half of the weight of this block to be able to keep it suspended. But here, since we have two pulleys, we have a leverage of twice. We have a leverage of 2, which is a quarter. So as you can see that half is 0.5, right? So half is 0.5. And 0.25 is half of 0.5. So we even need less. We are required to put in even less force to keep this weight suspended when we have two pulleys. Okay. So for C, we have 3 pulleys. Okay. All right. This is C, right? We have 3 pulleys, 2, 3. And we're going to draw a free body diagram for every pulley here. We're going to start with pulley number 1. We'll call this one pulley number 1. And I'm going to put the 1 here. And we have a tension going around it. I think you already have the hang of it, right? So we have T. It's going around pulley number 1. And then we have T1, which is attached to pulley number 1, and then it goes to around pulley number 2. So we will just account for this tension here. And this one is tension 1. And then we will draw a free body diagram for pulley number 2. So pulley number 2, we have T1 right here and T1 here, because you see this is T1. This tension is going around this cable, and then it goes to the fixture up here, right? So we have T1, and then we have another tension, another cable attached on pulley number 2, and it goes down. So we will just account for this tension, and we will call this T2. And then we have the last pulley, right? Pulley number 3. We have pulley number in T2. T2 coming from pulley number 2 right here, this one. And it goes around this pulley. And this one is still T2. T2 and T2. And then we have the weight W that is attached to the third pulley. And we will make 3 equations for every free body diagram. So this will be 1, 2, 3. Okay, 1. We have 2T minus T1, because T1 is facing down, is equal to 0, because we don't have, everything is in equilibrium, right? And then number 2, we have T1 and T1, which is 2T1 minus T2 is equal to 0. And then our third equation, we have 2 T2s. So 2 T2, and they're all facing up, minus W, because facing down, this is 0. And now we will solve for W and T2. The third equation, we will solve it first. So 2T2 minus W is equal to 0. If you solve for T2, you will get that T2 is equal to 1/2 of W. And if you plug T2 into the second equation, you will get that 2T1 minus 1/2 of W is equal to 0. If you move W on the other side, we'll get 2T1 is equal to half W, then T1 is equal to, we solved this already, right? So we had quarter W. And now plug this equation into the first equation. So we have 2t. Let me see. I don't know if you can see, but let me move this. All right. So now we have 2t minus t1 is equal to 0, right? So 2t minus a quarter of w is equal to 0. So then 2t is equal to quarter w, and then if you divide both sides by 2, you will get that t is equal to, I already know this, but it should be 1/8. So a quarter times 1/2 should be 1/8. 0.125. 0.125 is 1/8. As you can see, 1/8 is 0.125. All right. So we have that t is, when we have 3 pulleys, let me write this better. So t is equal to 1/8 w. As you can see, when we have 3 pulleys, we are required to use even less tension, less force we are required to put in to be able to lift up the weight and keep it suspended. So now we can just conclude that the more pulleys we have, the more leverage we get. The easier the weight that we are trying to pull is going to be. And we will move on to the next exercise. All right, so we have our second exercise, which is 3.56, and this one is not as easy as 3.58, okay? So, and this one, they said that a suspended mass M1 is equal to 50 kilograms. This is the mass 1. Neglecting the masses of the pulleys, determine the value of the mass M2 right here, necessary for the system to be in equilibrium. So this is a messy schematic. It's a messy diagram here that you have to cut into pieces so that this can be easier for you to solve it, because you cannot just take this whole exercise here and then just solve it. You need to draw free body diagram for every pulley here. And they said that we are going to neglect the masses of each pulley right here. So we will start drawing free body diagrams for every pulley here. We will start with pulley number A, okay? So we will start drawing a free body diagram for pulley number A, okay? So A, and so it is attached to a fixture up here. This, you see the bolts, and you see this figure here. This indicates that it is a fixture. So we will just call this F. And then we have a cable going around pulley number A, number 1, pulley A, okay? So this one is tension, and we will just give this T. All right, so let's move on to pulley number 2. Pulley B, we have the tension T coming to it. It is suspended up, and then we have the mass here. We also have the same cable going around, and this is T1 and T1, and there's nothing else, okay? So tension and same cable around, okay? And then we have pulley C here, And for C, there's T coming to it, which is facing up, which is T. And then T1, as you can see, it starts from where M2 is suspended at, and then it goes around pulley B, and it goes around pulley C. Okay, so then we will say that this is T1, and this one is also T1, T1, and T1, and then mass 1, M1 is suspended to it. So we will just give this M1G, okay? Because you know that weight is equal to mass times gravitational force. Okay, and then we will make a body diagram for this mass M2. Okay, so M2 is its own weight, which is M2 times G, and the tension of T1, because you see T1 here is going around, is attached to the mass 2. So, and this will be T1. And we are given that mass 1 is equal to 50 kilograms. We're just searching for M2. M2 is our unknown. Okay, given. And we will try to solve for M2. All right. I have my calculator right here. Okay. So the next step we have to do is make an equation for every pulley here, for every pulley system. So for A, we have F minus 2T, because T and T are facing down, is equal to 0, okay? And then equation B will be T, this is T, okay? T minus 2T1 is equal to 0. And for equation C, we have two T1s both facing up. So 2T1 plus T minus M1G, which is the weight for mass 1, minus M1G is equal to 0. Okay? And then for M2, okay, we will just call this equation D, is T1, which is facing up, minus M2G, which is facing down, is equal to 0. All right. So here is the thing. We have this equation right here, okay? But what we don't know is, we don't know what T1 is, right? So let's do this. For equation B, let's solve for T1. So we can say that T is equal to 2T1, because if you move the negative 2T1 to the other side, it will be positive, right? So we know that T is this, okay? And let's solve for C. So we know that C is 2T1 plus T minus M1G is equal to 0. Okay, so let's solve for T1 here, okay? And we know that T is 2T1, right? So we have 2T1 plus 2T1, because T is 2T1 minus M1G, right, is equal to 0. Oh, let's just move, okay, so let's move minus M1G to the other side is equal to M1G, because if you move negative M1G to the other side, it will be positive. Okay, so then we have 4T1 is equal to, what is M1? M1 is 50 kilograms, right? 50 kilograms times 9.81, which is M, because G is the gravitational force, and that is 9.81 meters per second squared, right? So, okay, that's how you find weight. So 4T1 is equal to, I'm gonna bring my calculator, and so we have 50 times 9.81, and that is 490.5. 490.5. If you divide by 4 for both sides, you will get T1 is divided by 4. We get T1 is 122.625. Okay, this is in pounds. And then we will get equation D. So the reason we did not use equation A is because we have one unknown that is not in any other equations. So we have F here. If you look at equation B, you don't have F, you don't have F here, and equation C, and you don't have F in equation D. So it will just be easier for us, and it would be time consuming just to solve for F or solve for T in F, okay? But if we wanted to find F, we can just plug it in because we found T1 and we can solve for T1 here, but we're looking for M2, right? So M2, then we use equation D. Equation D stated that T1 is T1 minus M2G is equal to 0. So we know that T1 is 122.625 is equal to, let's move M2G to the other side, which is 9.81, which is, because we know G is 9.81 times 9.81, because we moved negative M2G to the other side, it will be positive. So 9.81 times M2. Okay, so if you divide by 9.81 for both sides, you will get the value of M2. Okay, 9.81. So then M2 is equal to, so 122.625 divided by 9.81, which is 12.5 kilograms. Okay, so we have M2 is 12.5. So that's how you solve this problem. All right, as you can see, I broke this. So I was given a very complex body diagram here, so I just cut it into pieces just so I can find M2. M2 is right here. All right, so this will be the last problem, and this one is 3.55, and it says the mass of each pulley of the system is M, and the mass of the suspended object A is MA. As you can see in this pulley problem, we are accounting for the pulley's weights, okay? And they said the mass of each pulley is M, okay? And the mass of the suspended object, this object A, is MA. So they want to determine the force T, this tension here, necessary for the system to be in equilibrium, so that everything is suspended and it does not move. Okay, it stays as it is. So every time I tell you, whenever you start doing these pulley systems, they will give you this complex body system here, but if you break it into pieces, you will be able to solve this problem. And that's exactly what we're gonna do. Okay, 3.55. So we have our first pulley here, pulley 1. We have how many pulleys? 1, 2, 1, 2, 3, 4. 4 pulleys, okay? So 2, 3, and 4. All right, so free body diagram for the first one. So it is attached to a fixture. We will call this F right here. And then we have the tension going through the cable, one cable, going through the pulley. Okay, since now we are accounting for the mass of every pulley, we need to add another. This is the weight, which is M, because they said the system, the mass of each pulley is M. Okay, so this will be mg, right? And for the second pulley, we have the same tension going around pulley number 2. So let me get this closer. So I will just draw 2 here and the pulley, and this, there is T, the same T here that was on pulley number 1 is going through pulley number 2. Okay, so this will be T, and then there is another, and it goes around pulley number 2. So this is T again, and then you have T1 attached to pulley number 2, and this will be T1. And then pulley number 3, right? So 3. So for pulley number 3, we have T1 going around. Oh, see, this is important. We forgot to account for the mass of the second pulley, right? So this will be T1 and then mg. Okay, all right. So for pulley number 3, we said that T1 was going around it, T1, and T1, because same cable, and then T2, and the mass of the pulley. All right, so then for our fourth pulley here is so this is T2 going around it, so T2 and T2, and then we have the pulley of this, the mass of this pulley, which is mg, and you draw the mass of the object, which is A. You account for its weight, and then the tension of T3 here and T3. Okay, every time we have, after we draw the free body diagram, we have to make an equation for every pulley system. So for A, we have F minus 2T minus mg is equal to 0. For pulley number 2, we have 2T's minus T1 minus mg is also equal to 0. And then for the third pulley system, we have 2T1 minus T2 minus mg is equal to 0. And for the fourth pulley, we have 2 T2s minus T3 minus mg is equal to 0. And then our fifth equation, which is accounting the weight of the mass, A, we have T3 minus mag is equal to 0. All right, and we're looking for T, right? We're looking for T. So let's start with equation number 5, okay? So we have T3 minus mag is equal to 0, right? So let's solve for T3. T3 is mag, okay? Because we moved it to the other side, all right? So here, number 4. So 2 T2 minus T3 minus mg is equal to 0. First, let's use equation number 2, okay? And let's solve for T. So 2T minus T1 minus mg is equal to 0. So 2T is equal to T1 plus mg, right? And then divide by 2. So T is T1 plus mg all over 2, okay? So that's what T is. T is T1 plus mg over 2. But if you want to add in T2 or T3, but those are that is not what we're being asked for, right? We're being asked, but if you wanted to do that, you could just plug T3 into the fourth equation and then solve for T2, and then plug T2 inside of the third equation and solve for T1, and then use T1 into the second equation here and plug in for T1, and then you can find T2, and then you can find the real where MA is inside of T3. Okay, let's see. We can do that. So 2 T2 minus mag, because we know T3, right? Okay, minus mg is equal to 0. So let's solve for T2. T2 will just be mag plus mg, 2T2. And then T2 will be mag plus mg over 2, right? And then if you go to the second equation, you can plug in. So 2T1, second equation, right? We have already solved for T. If you plug in the third equation, I mean, so 2T1 minus T2, which is minus mag plus mg over 2 minus mg is equal to 0. And let's solve that one for T1. So 2T1 is equal to mag plus mg over 2 plus mg. If you divide by 2, T1 will then be mag plus mg over 2 plus mg is also all divided by 2, right? So this is T1. And then if you, oh shoot, I don't even know if you were seeing everything that I did, but then, because we know that T here, okay, and we've solved for T1, T will just be T1, which is T will be equal to MAG plus MG. This is divided by 2 plus mg, right? All this divided by 2. This is T1 right here. Plus then, okay, put this into this big parentheses, plus mg, all this then divided by 2, which is T. So this really is T for according when we are only looking for the masses. This is the real. If we knew what MA and M was, we could have solved. We could have gotten a real value for T. But since we do not, we would just leave this T unsimplified. And that was it.